All right, so we are going to keep solving equations, but before we do, down the one of the margins of your paper, doesn't matter which one, we're going to write all the things that we need to know to be able to solve these trig equations. All right, so first I'm going to draw a little hand for the hand trick. All right, and then I'm going to label the fingers with the angle they represent. Okay, it's a lovely hand. All right, and then I'm going to write what we do when we use the hand trick. So if we are finding the sine of an angle, it's the square root of the bottom fingers over 2. If we are doing the cosine of an angle, it's the square root of the top over 2. And if we are doing the tangent, it is the square root of the bottom fingers over the square root of the top fingers. Okay, so that's one thing we need to know. We also need to know the quadrant angles. And the quadrant angles are 0, pi over 2, pi, and 3 pi over 2. And the ordered pairs at those angles are 1, 0, 0, 1, -1, 0, and 0, -1. And if we are going to use that to find the sine of an angle, we're just going to give the y. To find the cosine of an angle, we're going to use the x. And to find the tangent of an angle, we're going to do y over x. All right. Another thing we're going to need to remember is that all students take calculus. That tells us where the original 3 trig functions are positive. All right, and then also for the hand trick, if we have an angle that's not in quadrant 1, we can still use the hand trick. So let's draw the angles for pi over 6 first. So pi over 6 corresponds with 30 degrees, so I'm going to get like a shallower angle. So in quadrant 1 is pi over 6. Quadrant 2 is 5 pi over 6. Quadrant 3 is 7 pi over 6. And quadrant 4 is 11 pi over 6. All right, we're also going to need pi over 4 in the other quadrants. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And then I think the last thing we need is pi over 3 in the other quadrants. Now, I may have to add something to here if we realize I forgot something, but I think this is it. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, and we will keep on practicing that until we do our test. All right, so over on the other side, we're going to call this lesson 5.3b, and we're still going to be solving trig equations. Now, these are all going to be in a certain interval, so we aren't going to have to worry about doing the plus 2n pi or plus n pi, but we are going to have to use some of the identities to solve these. So for example 1, we're going to find all solutions in the interval from 0 to 2 pi. So as soon as you see that we're in an interval, you're not going to do plus 2n pi or plus n pi. All right, so for A, we have the cotangent of x times the cosecant squared of x equals 2 cotangent of x. Now, we are going to use some identities, but we're also going to have to factor and do things we didn't have to do on the last lesson. So before we solve this, we do want to get everything on one side. So I would subtract 2 cotangent of x. Oh, I wrote a t there instead of an x. Let me fix that. Oh, I wrote, okay, sorry. There we go. Okay, now what we're going to do is factor out a common factor. And that, if we look at what's in front of the minus and what's after the minus, what they have in common is cotangent of x. And when I factor that out, I'm left with cosine squared of x minus 2. All right. So now, if these multiply to give you 0, that means that either cotangent of x is equal to 0 or cosine squared of x minus 2 is equal to 0. So we'll set them both equal to 0. Now, we don't have a hand trick or like a unit circle thing for cotangent, so we'll do the reciprocal. So if the cotangent of x is 0, then that would mean the tangent of x is the reciprocal of 0 or undefined. Okay, so for tangent that is either equal to 0 or undefined, we're going to go to this right here. So for tangent to be undefined, we need 0 in the denominator, which means we're going to want our x to be 0. And so there are two angles where the x coordinate is 0, and that is when the angle is pi over 2 or 3 pi over 2. So we have two of our answers, angles that we can put in to the original problem and have it give you a true statement. All right, so now the other one, we have a little more work to do. So we are going to have to, oops, I didn't mean to do that. We are going to have to solve that for cosine of x. So the first thing we would do is add the 2, and then we would do the square root, the positive and negative square root. Now, the square root of 2 is like 1.4 something, and we hopefully know that when you take the sine or cosine of an angle, it always gives you something between -1 and 1. So this is actually not possible, because the cosine of an angle is always between -1 and 1. So that's too big and too small. So we won't get anything from this answer. Our only two answers are pi over 2 and 3 pi over 2. Okay, so that's kind of the stuff we're going to be working with today. Okay, so let's look at the next one. So for B, we have 2 cosine squared of x minus 5 cosine of x plus 2 equals 0. All right, now this is going to be like good old-fashioned factoring. So this is a trinomial, kinda, So we do our 2 parentheses, and what we put here and here have to multiply to give you 2 cosine squared of x. So that's going to be 2 cosine of x and cosine of x. All right, and then this plus sign tells you your signs are going to be the same, and then this tells you that they're going to both be subtraction. And the only way that we can multiply to get 2 here is going to be 1 and 2. So we have to decide where to put the 1 and where to put the 2. We wouldn't want to put the 2 here because it has a common factor with that 2. So we would have to put the 1 there and the 2 there, and hopefully that gives us the 5 in the middle that we're looking for, and it does. So when we do the outside, we get -4 cosine of x, then that gives you -1 cosine of x, and they combine to give you the -5 that you wanted. Okay, then I'm going to set each of these equal to 0. Forgot the equals. And then solve them for cosine and then see what answers we can get. Okay, so for cosine on the hand trick, we do the square root of the top fingers over 2. So for this particular problem, we want 1 top finger. Right? So if we go to the hand, the finger that has 1 top finger is pi over 3. So pi over 3 is going to be one of our answers. But we have to know that cosine is also positive in quadrant 4. So we need pi over 3 in quadrant 4, which we can see over here is 5 pi over 3. All right, and then on this one, we're going to add the 2. And then start thinking, can cosine of x equal 2? So it's the same issue we had up here. When you take cosine of an angle, it has to give you something between -1 and 1. This is too big, so it's not possible. So our only answers are the pi over 3 and the 5 pi over 3. All right, we are going to do a couple more. For C, we have the cotangent squared of x plus cosecant squared of x minus 7 equals 0. Now this one we can't do that old-fashioned factoring yet because we have cotangent and we have cosecant squared. So we're going to need to change one of those to the other one. And so looking at the identities, I think it might be a little easier because we won't have to worry about subtraction signs if we take cosecant squared of x and use the Pythagorean identity to change it to 1 plus cotangent squared of x. Now, if we had gone the other way and changed cotangent to cosecant, it would still work. I promise you'll get the same answer, so don't stress too much about it. Okay, so now I'm going to combine my like terms. So I would add my cotangent squared of x's together. I would also add 1 and -7. Okay, then I'm going to add the 6, divide by 2, take the square root. Now don't forget, we do have to take the positive and negative square root. Okay. So we're in a situation similar to what I had on A. Like we don't have a hand trick or anything for cotangent. So if we end up with cotangent, we're going to do the reciprocal. So the tangent should be 1 over the square root of 3. All right, that is going to be a hand trick question, and because it's positive and negative, it's going to come from all 4 quadrants. All right, so let's look at the hand trick just to make sure we're right. When we're doing tangent using the hand trick, it's the square root of the bottom fingers over the square root of the top fingers. So what we want is 1 bottom finger and 3 top fingers. All right, and if we're looking for that finger that has 1 below and 3 above, that's going to be the pi over 6. So x is pi over 6 in quadrant 1, right? And then pi over 6 in the other quadrants as well, because we're getting from all 4 quadrants. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All 4 of those answers work in this problem to give you a true statement. All right, we have one more. For D, we have tangent of x minus secant of x equals 1. And this is one of the tougher ones, and I know you guys are doing great with this, but this is one where I wouldn't expect you to know what to do if you had never seen one of these before. Some of these other equations, we've done similar things, but this is brand new. So tangent of x minus secant of x is not anything significant in trigonometry. So what we're going to do is move one of those to the other side. And the one that would be more logical to move would be the secant, because when we move it on the other side, it becomes positive. So let's just move secant of x to the other side. Okay. Now, if these are squared, then we can use some identities to do things with. So let's go ahead and square both sides. Now again, you wouldn't know to do this without me showing this to you, so don't worry if you feel like you're a little confused about what's going on. Now to square this binomial, I'm going to square the 1, multiply them together, and multiply by 2, and then square the secant. Okay, so on the left, or on the right, we have all secants, multiple secants. On the left, we have just a tangent, so let's just change that tangent so we have all secants using one of your Pythagorean identities. All right, so now let's get everything, well, let's just get the secant squares together. Okay, so that works out nicely because the squared cancels out, the squared term cancels out, so we aren't going to have to factor this one in the end, so that's good. So we'll get the 1's together, we'll divide Okay. Now, we do not have a rule for secant, so we'll do reciprocal. So the reciprocal of -1 is -1. The reciprocal of secant of x is cosine of x. So for 1 and -1 on sine and cosine and 0, you're going to want to use the quadrant angle information, which is this part right here. All right, so we had that the cosine of x was -1. And so if we're using these quadrant angles for cosine, we're going to use the x coordinate. So we want an x coordinate that is -1, and that happens right here. So our answer should be pi. Now, one thing that happens whenever you square both sides to solve an equation, all kinds of equations, sometimes you get extraneous solutions. All right, so it just takes a second to take that pi. We're going to plug it into the original equation. So it would be tangent of pi minus secant of pi equals 1, and just see if that is true. Okay, so for tangent of pi, I'm going to go back because pi is a quadrant angle. And I'm going to go back to this blue area. Tangent, we're going to do y over x. So at pi, our y is 0 and our x is -1. So 0 divided by -1 is 0. And then minus. So secant is going to be the reciprocal of cosine. So for cosine of pi, you're just going to do the x coordinate. And so the reciprocal of -1 is -1. And that checks out. So pi is perfectly good answer. All right, so what I want you guys to do for your assignment is page 371, 25 through 30, 33 through 36, and number 38.